Okay, here's the actual equation of the hyperbola that we're looking for. Here's a picture of its graph. And the question is, how do we come up with this equation? Given that the foci are at -2, -4, comma 2, and 6, comma 2. And one of the things that you want to focus on is, where is the center of the hyperbola? This HK is the center of the hyperbola. And the center has to be halfway between the foci, or it's the midpoint of the segment joining the foci. So the vertices of the hyperbola, the foci, all lie along this line. And so the average of these x coordinates is 1. So when x is 1, y is 2, that's got to be the center. So that's how I came up with this 1, 2. We're also given that the point 5, 2 lies on the hyperbola. Well, that's this point right here. That has got to be a vertex. That's the only way that point can lie on the hyperbola, because it's on this horizontal line, y equals 2. So that tells us that 5, 2 is a vertex. So the distance from the center, which has an x-coordinate of 1, to the x-coordinate of this vertex is 4. That means A is 4. And of course, C is the distance from the center to a foci. Well, that goes from an x-coordinate of 1 to an x-coordinate of 6. That's a 5. And for a hyperbola, the relationship between C, A, and B is C squared equals A squared plus B squared. So 25 equals 16 plus B squared. Solve for B squared, you get 9. That's where I got this 9. This is A squared is 16. So there you go. Now, if I go to Desmos and look at this hyperbola, which I've graphed here, there's the center at HK, 1, 2. A is 4, B is 3. There's the standard form for the equation of hyperbola. That's the one we're looking at. There's the foci at 6, 2 and -4, 2. Center at 1, 2. And if I could show you the asymptotes, there they are. If I expand this link, you'll see the equations of those two asymptotes in red here. And if I hide those asymptotes and show the distance to the foci, the definition of a hyperbola is the set of points in a plane that have a distance to one foci minus the distance to the other foci is a constant. And you can see if I move this point x sub 1, y sub 1 on the hyperbola, at least on the upper branch, the distance from one foci, which is d1, minus the distance to the other foci, which is d sub 2, calculated down in here somewhere, remains constant. That distance is always 2. That's the definition of a hyperbola. And that distance is 2a, which is the distance from the center to a vertex. That distance remains constant. It's 8. Okay, so I'm going to post the link to this graph in the answer to this question. Hope that helped. And if you have any questions, post a comment.